is formed. A white precipitate is formed, and the precipitate dissolves in excess nitric acid with effervescence. So we are having lead 2 nitrate, we are adding it to the test solution, or that solution that you're testing. Then we also add excess nitric acid. So we are saying that we form a white precipitate that will dissolve in excess nitric acid. So if there is any carbonate being formed after adding nitric acid, if there is any carbonate formed or hydrogen carbonate formed, it is going to dissolve in excess nitric acid with effervescence, meaning that we shall have the formation of carbon dioxide gas. And B, sometimes barium nitrate solution or barium chloride are used with lead 2 nitrate in case of lead 2 nitrate. So this is what we mean. You get your carbonate. This time we are using sodium carbonate. Add there lead 2 nitrate. Remember, we have just said that we can either use lead 2 nitrate, or you can use barium nitrate, or you can use barium chloride instead of lead 2 nitrate. So this one can be substituted to any of these: barium nitrate, barium chloride. So we are forming lead 2 carbonate and sodium nitrate. That is after adding some nitric acid, not in excess. That's why we are able to. This is after adding lead 2 nitrate solution. Here we are having the radical exchange, whereby sodium takes up the nitrate and lead also takes up the carbonate. So we come up with lead 2 carbonate and sodium nitrate. Once again, that is when we have the carbonate and the lead 2 nitrate. But remember, we said we add nitric acid or excess nitric acid. So on addition, remember this is a soluble salt. On addition of nitric acid to resultant products, the lead 2 carbonate formed is going to dissolve in the nitric acid, and we shall form the corresponding salt, which is lead 2 nitrate, water, and carbon dioxide. So this carbon dioxide gas is the one that causes the effervescence. So the effervescence is carbon dioxide gas. So the moment that happens, you know that you have a carbonate or hydrogen carbonate. So after that, after looking at how we can test for a carbonate or hydrogen carbonate, let's pick out one carbonate and look at it in details. So we look at sodium carbonate. We have just picked one, but this is the common one at this level. So we look at laboratory preparation, and this is the setup or the diagram. So basically this is what happens. You are going to have calcium carbonate and dilute hydrochloric acid. So when I have dilute hydrochloric acid and calcium carbonate, and I add the acid onto the marble chips, or what we call calcium carbonate, we shall have the formation of carbon dioxide gas. So in this case, in this flask, we shall have effervescence of a colorless gas. Here we are forming carbon dioxide gas, which will pass through this derivative tube, and it goes into water. It goes into water. Why do we pass it through water? It is to absorb traces of the acid, or what we normally call hydrochloric acid fumes, or at times we can say hydrogen chloride gas or fumes, which normally accompany hydrochloric acid. So whenever you use hydrochloric acid, those impurities of the fumes will come up, and you need to remove them so that you can have a pure gas. So carbon dioxide is passed through water to absorb the traces of the acid. When the acid traces are removed, to mean that we are remain with our pure carbon dioxide. So it will move, to continue moving, it comes down into, this is a setup. This is where we have sodium hydrogen carbonate, we have there ice cold water and sodium hydroxide. So this is what happened. When the gas comes, it is going into a test tube which is containing sodium hydrogen carbonate, which is containing sodium hydroxide solution. So the moment the gas enters or meets sodium hydroxide, automatically we shall form sodium carbonate. Then why do we have sodium hydrogen carbonate? Remember, the gas keeps on being formed, so we shall later have an excess of carbon dioxide, which will lead to the formation of sodium hydrogen carbonate. This is something we talked about before. The moment you have excess carbon dioxide and you dissolve it in sodium hydroxide solution, we shall form a white precipitate of sodium hydrogen carbonate. So we shall have two products, but the excess one, the one we are interested in, is sodium carbonate. So when we form sodium hydrogen carbonate, remember our interest is not in the formation of sodium hydrogen carbonate, but the diagram shows that we have formed sodium hydrogen carbonate. We are forming that because of having too much carbon dioxide which is being produced. So let's see how we can get our product. How can we get sodium carbonate after using this diagram? Procedure. Those are steps involved, or what happens within the other diagram. 1. Bubbles of carbon dioxide pass through a fairly concentrated sodium hydroxide solution until in excess. So this one comes after the production of carbon dioxide. You pass it through a fairly concentrated sodium hydroxide solution until in excess. White precipitate of sodium hydrogen carbonate are formed. That is what we saw in the diagram according to the equation. So this is how it happens. We have this equation somewhere. We are forming sodium carbonate and water. So in excess, that's when we shall form sodium hydrogen carbonate. Then we say that is a white precipitate. In other words, if you combine all these, they will give us a white precipitate. That's why we are calling them white precipitate. After combining all these, the sodium carbonate, water, and excess carbon dioxide, so we come up with that white precipitate. So the white precipitate of sodium hydrogen carbonate is filtered off, washed, and dried. So the sodium hydrogen carbonate is then heated strongly. So we are now in the final stages of the formation of our main product, which is sodium carbonate. So get the already formed sodium hydrogen carbonate, heat it strongly, apply much heat until no further change. Or we say until no further water vapor and carbon dioxide are given off. Why do we say until no further water vapor and carbon dioxide are given off? We are forming sodium carbonate which is stable on heating. So you have to heat and heat until when you're sure that you have sodium carbonate. That is on heating. So the water will evaporate, then carbon dioxide will be given off until there is no further change, or until no further water vapor and carbon dioxide are given off. So this one leaves a white powder of sodium carbonate. This is supposed to be sodium carbonate, not calcium. So we have the equation. This is sodium hydrogen carbonate then it is heated strongly, it forms sodium carbonate, carbon dioxide, and water vapor. So this is the water vapor that we are talking about. So you have to heat this one until